Okay, so we're looking at sequences in series. We have an artist creating a tile mosaic. She has 4 green tiles in the first row. 4 green tiles in the first row. 11 tiles in the second row. I'm going to start, this is a sequence. If it's just a list of numbers, I just have a sequence. And then I have 18 tiles in the third row and 25, there's my comma, 25 in the fourth row. So this would be A sub 1, A sub 2, A sub 3, and A sub 4. Right? I have 4 terms in my sequence here. Now it says if she continues the pattern, how many green tiles will she use in the 20th row? So we have this pattern going here, and then we're interested in A sub 20. That would be the number of tiles there in that 20th row. Well, the question is this arithmetic or geometric? And so you're going to look at the difference or the ratio. If it's arithmetic, there's going to be a common difference. Okay, so if I have a common difference, I'm going to subtract, right? The difference, you subtract. So I'm going to take 4 or 11 minus 4, right? 11 minus 4, and that equals 7. Right? That difference is 7. And then I'm going to take 18 minus 11, right? 18 minus 11, and that is 7 as well. I have to check them all, and then that is 25 minus 18, 25 minus 18, that is also 7. So that is my common difference, all right? D equals 7, all right? And so that tells me that this is an arithmetic or arithmetic sequence, right? Because I'm not adding them all together, I'm just trying to see what's in this, how many are in this last row. And I have a formula on my desk here that says if I have an arithmetic sequence, right, then I need to, which has a common difference, a first term, and then I'm trying to find the nth term. All right, this is the function that I'm going to use to generate that term. So I'll go back and I'll just use that function. I'm just going to substitute that function into my calculator. So I'll go so I've got my calculator, and I'm going to put in just into that, I'm just going to put it straight into that formula that I'm looking at from my sheet. All right, it says A sub n, so that's my y1, my y equals, and I'm going to put in the first term, A sub 1, which was 4, right? There was 4 tiles in that first row, plus, and then I'm going to use x instead of n. So I'll say x minus 1, and then times d, and the difference, the common difference was 7. Okay, every row had 7 more tiles than the one before it. All right, and then so now if I look at the table here, and I can see when x is 32, that is going to be 221 tiles. Oh, no, I don't want 32. That was a different one. I'm looking at the 20th row. Right, when x is 20, it's 137 tiles there, okay? I could also do alpha trace. Oops, not there though. I gotta quit out of here. I could do alpha trace, and there's my y1, right? That's where I put the function. And then remember, my domain is the number going in, so the domain would be 20. I want to know the 20th row, how many are in there. And my range there would be 137. 20 goes in, 137 comes out. And so this would be the answer. All right, so now we have the number 2. It's nice because we don't have to figure out if it's arithmetic or geometric. Oh, sorry. That is the same thing, basically, except, so I was thinking it was the same problem, but it's not. It's an arithmetic sequence. All right, so I know I'm going to use I'm going to have, I'm going to need the first term, right? I'm going to need a sub 1, which is 4, and I need to have my common difference. All right, well, if I have 2 terms, I can subtract them. So 9 minus 4 is 5. So my difference is 5. My common difference is 5. And so I would just put that into my function, which I've already got that in there, which is nice. I can find my calculator. Why does it keep disappearing on me? I think that's it. Okay, so we'll go ahead and I'll go to y equals, and what changed was now, oh, actually it still is 4, but what changed here, the first term is still 4, but the common difference is not 7, the difference is 5. All right, and I'm still looking for the 20th term, so there it is, it's 99. All right, and again, I could do the alpha trace. Oops. All right, I could do alpha trace instead. Oops, I don't want to do that. Keep doing that. Quit out of there. And then do alpha trace, y1, and then my domain, what's going into the function would be 20 again. And then what comes out is the range, and that's 99. Okay? All right, very good. So now what we're doing, it says what is the sum of the series, okay? And so we have this summation function, and it's already there for us, so all we have to do is put that on the calculator. All right, so this right here is going to generate a sequence, all right? That's going to generate a list of numbers, and this is going to add them together. So here we go. We'll just get the calculator going here. All right, so my summation was math 0, and there it is, and I'm going to just say x is going from 1 to 30. Oh, oops, I got to make it jump up. So 1 to 30. All right, now I need to tell it how to generate this sequence of numbers, and that's a function, so it's 2x plus 2. Okay, and then I'll just hit enter, and that's going to add up all the numbers in my sequence, and I get 990. And then we'll go to the next one. So it says, what is the 10th term of the geometric sequence? So it tells me that it's a geometric sequence. All right, so I need, as always, I need to know the first term, which is 1. So a sub 1 is 1. And I need to know, since it's geometric, right, I need to know r. I need to know what is the ratio, the common ratio. So I'm going to take 4 divided by 1. So r is going to be 4 divided by 1. Okay, so r is 4 over 1, so that's 4, right? My common ratio is 4. And so now I'll just go to my, I just want the 10th term, right? I'm not adding it up together. It's not a series. It just says what is the 10th term. So I need to look at what is the formula for that. And so I'm going to find it's a geometric sequence, right? So geometric is right here, all right? And this tells me a sub n, you take the first term all right, times the common ratio, and then this n minus 1 is now an exponent. This is an exponential function. All right, the arithmetic was linear, right? This is linear. Geometric is exponential. Okay, so here we go. I'll just put that in to the calculator, right? And I'll get my answer. Okay, so it is a geometric function, so I'm going to go y equals, and it was, you start off with the first term, right, just like before. The first term was, what was the first term? 1. All right, the first term is 1. Right, so I've got 1 times, and then my ratio was 4, and then it's exponential, so it's to the x minus 1 power. And I go over, and I'll look at the table, and what term did we want? So we're finding the 10th term of this series, right? Or sequence, the 10th term, and so a sub 10 is going to equal, and I'll look at my calculator, and I'll put that in. So I can look on my table when x is 10, and I get 262,144. So there we are. It looks like it's C. Okay. And then remember, you can do it with as a function as well. I can go alpha trace, enter, and then I'll put in 10 as my domain, and then what comes out is the range. And that's kind of nice because then it's easier to see it. All right, so 262, 144. All right. So the next one, we have a sum of a geometric series. Okay, so that's going to be the summation, right? So a sub 1 is 1, right? And then my ratio, well, let's see, I'll take 1/3, right? Divided by 1, oh, well, that's 1/3, right? Anything divided by 1 is itself, all right? So r is 1/3. Oh, but look, we have the dot, 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 okay? So that is infinite. It goes on forever, right? Well, so I need to look at r. Is the absolute value less than 1? Yes, the absolute value of 1/3 is 1/3, and then 1/3 is less than 1. So I know that it is converging towards a number. And so I can find that number where it's converging towards, where it's heading towards. Kind of like the idea of the asymptote with the end behavior as you go to infinity. All right. So we're going from, actually, so we have a formula. So I'm not going to do my summation. All right. I have a formula, S, right? The sum of an infinite series. This is an infinite series because it never ends, right? This is an infinite series, and the formula there, and that's, again, that is on your chart. You need to know where it is. So look on your table. It is down here at the bottom. You have the sum of an infinite series is to take the first term divided by 1 minus r. Okay? So, well, that's what we'll do. That's easy. All right, so I'm going to take the first term, which is 1, divided by 1 minus r, which is 1/3. Okay, so I'll just put that into my calculator. All right, so I have alpha 1 equals, because it's a fraction, and a sub 1 is 1, so the first term divided by 1 minus r, and r was a fraction, less than 1, so it is going to converge, and we get 3/2 is what the sum of that series is going to be. All right, so the sum is 3/2. All right, so now we have, what is the summation notation for the series that starts with 5, all right, and ends with 105? All right, well, all of my choices here are linear, right? They're all arithmetic. It's definitely an arithmetic series. Okay, and so now we need to figure out, well, what is going to be the common difference? All right, if I subtract these, what do I always get? And so it looks like D is equal to 2, right? And the first term, A sub 1, is equal to 5, right? So which one of these is going to give me a first term that is 5? All right, so let's see, and what we're looking for here is when n is 1, all right, when n is 1, which one would equal 5? Okay, so and what you could do is I'll go ahead and put that in there, and then my last term is going to be 105. I think that might be the best way to go. So let's just try F, and I'll put that into my calculator. So the sum is going from 1 to 51. All right, so I'm going to do math, 0, I get my summation, and x is going from 1 up to 51. And the function is 2x plus 3. And I'm just going to see if that gives me a list of terms. Actually, that's going to add them all up. So I want to see just the list of the terms, so I'm not going to do the sum. All right, so let me go ahead and quit out of this. I'm going to go to, I'll go ahead and clear that. I'm going to go to y equals, and I'm going to generate these terms and see if I can get it where I've got a list of terms, 51 terms, right? Or 50 or 51, that's the question. Is it 50 terms or 51 terms? So let's, oh, I don't want to do that. I want to clear, quit. So go to y equals, and I'll clear that out. And so I want to do 2x plus 3. That was the first function. Right? Remember we said the function here is what generates the terms. So if I look at that, and let me see, I've got x sub 1 is 5. So that looks good. That first term would be 5 if I have 2n plus 3. All right, so g is out and I is out. All right, and you can tell that if I put 1 in here, 1 plus 3 is 4. And if you put a 7 in here, 7 plus 3 is 10. All right, so we can tell that pretty easily. All right, so we've got our first term is 5. Well, let's see what the 50th term, right? The question is, do we go to 50 or do we go to 51? So let's see. Well, I'll go ahead and do my alpha trace. All right, and I'm going to put in 50. If I go to 50, what's going to be the 50th term? Oh, 103. All right, so we don't, if we go to 50, our last term would be 103. So we actually have to go, I'll just arrow up, I guess, hit enter. And I'm not going to go to 50 though, I'm going to go to 51, and I'll hit enter, and now I get my last term is 105. Okay, so it's going to be this guy, right, going from 1 to 51, and then this is the function that's going to generate this. If this was a sequence, that would generate that sequence. The sigma is what is going to add them all together. All right. So, looking at the next one, it says evaluate this series. Okay, if I want to evaluate something, I just do it. All right, just put it in and see what you get. All right, so here we go. We'll say that's a summation, right? So I've got to get on my calculator here. And it's a summation, so I'm going to do math 0. And I'm going from x, it looks like minus, but it must be equals. X equals 2. So x is going from 2. So it doesn't have to start out at 1. It can start at anything and go to anything. So 2 to 4. And then my function there is a fraction. So I'm going to do alpha y equals, to get my fraction, and it's going to be 10 over 4x. All right. And I'll hit enter. Okay, and so that would be 64/24. And so that's the question is, well, I guess there J has 24ths. All right, so is that 2 and 17? So let's take 65 and divide by 24. Divide by 24 and see if I get 2. Yeah, that's 2. And then I've got 17 left over. Okay, probably if I took this fraction, 0.7083333 times 24, that will give me my 17 remainder. All right, there's my remainder. All right, so it's J. All right, and that is all we need to know about sequences and series. Okay, good job on that. I hope you're getting all those right on the JLabs, and good job on the JLabs. Keep sending them in. All right, see you later. Bye.